Okay, we'll see how that goes. Now, now, when you draw this thing here, what you guys need to do is draw the external forces that we just calculated. So we know that there is an external force. Do you guys agree? This one was already on here, and we knew it was 5 megapounds. So draw that on. Draw your external forces on. We knew there was an external force here of a 150 pound. Make sure you draw your arrows on too, okay? We knew that there was an external force over here. We said it pointed up, and we said it was 350 pounds. You guys need to stop me if I say anything silly, okay? Notice I did not bother to draw what? Yeah, the RAX, because it was 0, so it's really not that important. Hey guys, what's hard for me is to look at mine, because I have all the answers, see how much other stuff there's drawn in here. Did I get everything that we had on the previous page? Did we get them all? Okay. Now what we need to do is isolate one of those members. Looking at this problem, I will tell you this. It is very difficult to isolate B or D. Look at all see how B has like 3 different members and 2 of them are angled members? That makes it very difficult to solve. Now, C isn't quite as difficult because they're all perpendicular members, but the only thing we know about D is this one thing. So I would say don't start at D. If we go to A or we go to C, those are good because we should know that there's only 2 things, and we already know something that will help us. So pick A or D, it doesn't matter, but pick one. A, okay, that's just paper. And we're going to start by isolating A. Okay, I'll do that on this page. A looks like this, but just focus on A. This is what A is. We know that A travels up to B. We know that A travels over to D. Does everything we've drawn so far make sense? And we know that there is a upward force here of 350 pounds. Everything I draw so far makes sense, right? This is called isolating members. Now what we need to do is focus on anything that's diagonal and don't let it be diagonal. Okay? So you guys see AB? I need you to make it into a right triangle. Maybe a better right triangle than I did. We're going to focus entirely on, we will not consider the diagonal yet. Okay, the diagonal is a member and AB is a member. I want you to label this as A, B, Y. Label this as A, B, X. Do you have any questions so far on anything I've labeled? Everything's okay so far? For each joint, the sum of the forces has to be 0. That was a big concept I just said. I hope it didn't fly in one ear and out the other. At each joint, the sum of the forces happens to be 0 for your joint not to be 0. So what we're going to do is we're going to do a sum of the forces in the y direction just for this particular joint, and we have to do a sum of the forces in the x direction just for this particular joint. We're going to have to do this with several joints, so stick with me. You'll see why this takes so long. Doesn't look like a big problem with the triangle, but it's a lot of math involved. All right, look at all the y directions. I see highlight the Y things maybe in the green. I'll highlight the Y things in green. Do you guys see how this should be green and this should be green? Because those are my Y directions. Okay. Those are the only two Y things I see. So what I'm going to do is I'm going to grab my pen and do this. A, B, Y plus 350 C equals 0. Does that make sense? The two green lines? The two green lines are my vertical lines, and those have to equal 250. Or excuse me, together they have to be 0. So I can solve here, can I? What is ABY? Good. What does that mean? This negative tells me my arrow direction. How should I point my arrow on ABY? Down. We're going to draw a down arrow. I'm going to grab my pen, and I'm going to write 350. Now notice I didn't write negative 350, I just wrote 350. That's because when you label your diagram, you just label it with the number. What does the negative, where is the negative on my diagram? On the arrow. This is negative 350. Let's do the same thing for X. What color would, I don't know, orange? Would that stick out? So in orange, I see, or in X direction, I see these two. You guys see those two? So let's go ahead and do those. And just go highlight it. This one we know what it's called, right? We know that one's called ABS. Does anybody want to take a guess as to what this one's called? A. Yes, that.
Wait, should this be parallel?
Yes, I drew them very close.
Okay,
Yeah, they should be parallel to each other, yeah. That one should not be diagonal at all. You don't, because AD, that's a good question. Brandon said you don't need an AD, an X on the AD. You could put it on there, but because it's only in the direction, X direction, you don't need it. Yeah, great question. Do we know either of those? Do we have a value for ABS? Do we have a value for AD? We don't. So what that means is we're going to have to come back to this. You don't have to write that down. I'm just doing that so hopefully if I was scared for the camera, I'll watch it. We're going to have to come back to that. All right. Do you guys agree with me that AB and AD are the members?
Yeah.
Good. That's important. We need to solve for AB and AD. That's like the whole end goal. So, that's right. The stuff in the middle is imaginary. The blue lines are really imaginary, but the blue lines are going to help us get AB. All right. Now, give me a second because I want to look at this. All right. Now, we need to find theta, which is right here, by using known foot length. And we need to find theta by knowing a given foot length. Now, we'll go on the drawing. I certainly hope they were on the drawing. I go back. Now, before I go back, I'm going to draw this. I'm going to draw this triangle. Okay? This is right here. Let's go back. Look at this here. Let's go here. You guys see that we use the bottom of theta to be represented with 3. In the vertical, or the, I guess this would be, what is this? This is the what theta? Adjacent opposite hypotenuse. This would be adjacent. What would this one be? Opposite. How is it? 4. Good. So we have the adjacent is 3, the tall is 4, so we go back here, here, and we're going to say this could be represented by 3 feet. This could be represented by 4. If we went back to the original, we'd say, oh yeah, that triangle actually does represent a 3 and a 4. So now, if I have an opposite and I have an adjacent, what trig function can I use? Tangent. Tangent of theta equals which one over which? The 4 over 3 or 3 over 4? 4 over 3. A lot for one little problem in this one. Now, from geometry or from trig, how do you solve for theta? Do you remember how to do that on your calculator? Second and. So get your calculator and type second and on your calculator. If I'm not mistaken, business math actually makes you write down second and instead of just doing hand -1. So you guys use it? Okay, good. So I'll write it on here, that way Eric and Kyle and kind of know what I'm doing. So second tan of 4 over 3. And we will do 4 significant digits when you give that to me, because that's what I have on my paper. What do you have? 5313. Right. For those of you who did geometry, you did this, and you didn't do it a lot in geometry, but we did talk about how to find this angle. Okay, now what we can do, this is fun. Now what we can do is we can put, I actually really enjoy this. I think it's so much that I really enjoy this. We can get rid of the unknown theta, grab my pen, and do 53.133 in there. Which I did. Okay. How can I find, I'll write some directions here. Use the new 53.133 to solve for A, B, X. So look at that picture up there. I'll draw the triangle. I won't do this every time, but I'll draw the triangle for you now. You guys agree we have 53. We have 5313 right there in that little itty bitty corner. We figured out that this is 350 pounds. Right? We figured out that was 350 pounds. What is this? Is this opposite or adjacent or hypotenuse? Opposite. If this one right here is A, B, X, is that opposite, adjacent, or hypotenuse? Bless you. That's adjacent. We can use tangent again to help us solve for ABX. Can you see that? So we do tan. We do tan of 53.13 equals, look up on the top. Good. You can put the negative on there. You don't have to. It won't matter to me because I'll ask you where the arrow points in a second. Over ABX. Now here's where you need to have not only geometry skills, but you also have to have some algebra skills. Here, you ready? I'm just going to teach you the shortcut based on how to do it for real in geometry. But when you have the missing thing on the bottom, all you have to do is switch that. So watch how it, literally is what you can write. You can write ABX equals 350 over tan of 53.1. And then finally, you guys can tell me ABX equals, type that into your calculator. Good. 262.5. You know, we got 262.5? Good. Now, here's the kicker. I'm not going to let, smart guys, can you have negative 265.5? Okay, good. I'm I'm not going to worry a lot about the negative right now, because here's what we can do. This is where I hope Derek and Kyle kind of can hear my voice, because this is really important. Guys, follow AB. Follow AB. You guys seeing what I'm doing here? This points down, right? So, does it make sense that if this points down, this has to point to the left, come back to the purple line? Then this would point to the left. The instant that I turn this down, I should have, the instant I do this down, I should have drawn that to the left, because that is the angle of this line. So I'm going to get my orange highlighter back. I'm going to go back here. I'm going to draw an arrow pointing this way now. And in orange, I'm going to label it as 262.5. And it goes to the left. Well, I'm going to grab my purple, because what that tells us is that if this one points down and this one points to the left, guess which way this purple points? It's got to follow the arrow. So it's got to point down and to the left. So draw that arrow on. Since we know which way that purple arrow goes, we're going to take this, we're going to go back to our separated drawing, and you better put an arrow pointing that way. That was a really stubborn arrow. Let me fix it. Everybody draw an arrow pointing that way. Remember, this is where all your final answers are going to go. Okay, another big concept. If this one's pulling this way, they always have to pull in opposite of each other. If this one's pulling this way, this one's going to pull. Yeah, this way. So once you get that arrow direction, you definitely want to put those on anywhere that you can. Now go back to here. We have almost everything we need. Where can I put this number up above? Where can I put this number up above? That's right. I can put it back in my orange. So this is going to go back to my orange equation. Okay, so instead of ABX, I'm going to replace that with, why am I replacing with negative 262.5? Because it's linked to the left. Let's see, how should I write this? Thanks for watching. Negative because it went left. There we go. Plus AB equals 0. So what can we conclude about AB? It equals good. Equals a positive 262.5 pounds. And since it equals a positive 262.5 pounds, where's the point? What kind of arrow? The right. Hey, guess what? Is AB a number? That means I should go back to my member drawing. I can draw an arrow right here. Didn't we just decide that was how it was pointing? And if it's pointing that way, how do you guys think this one's going to point? Opposite. So if this one's pointing towards the middle or it's pointing right, this one needs to point towards the left. They always face in opposite directions. We'll talk about what that means in a second. And not only did we figure that out, we just solved for a number. So I'm going to go back here, and I'm going to put 262.5 pounds. All right, this is where it's opposite of what you want to say. Remember how we talked about tension and compression being opposite when I had the draws up here and came over to the middle? Was it Sydney a McKenna pushing on you? in 262.5 in tension. I know it's obviously what you want to say, because you want to say that it's pointing in, so it should be compression, but you're worried about what the member is doing in the action. All right. The only other thing, I wish I had a little room right here. Just pretend this is on the same page. The only other thing I want to find from A, we should be able to use A squared plus B squared equals C squared to solve for member A, not AB, AB, the diagonal one. Do you guys remember how we haven't solved for that diagonal one yet. Just because I don't have it from the last page. This was my triangle. We figured out that this was this 350 where I have my hand? Okay. What was this one? 262.5? So as far as I'm concerned, you could use, if you guys wanted to, you could use sine or cosine if you would prefer. I just think most kids do better with A equals square. So here we go. Put a big square root. That's 350 squared. Notice I'm using all positives with this because it's squared, it's not positive anyway. Plus 262.5 squared. Put that into your calculator all at once. And tell me how much force AB has. And before you did this for me, good. So AB 437.5 pounds. I don't care if it's positive or negative because I already have my arrows drawn. So I don't care about if it's negative or positive because I already have my arrows drawn. So I'm going to go right here and I'm going to write the fact that this is 437.5 pounds. I haven't thrown the AP on here yet, right? 262.5. I definitely put it pressure on there. And I'm going to go back one more. This is where you put your final answer. This is your final answer. Yeah. You're solving for all the blanks. That's sorry. That actually picked up very good. Solving for all the blanks. You're solving for all the blanks? They're miserable. I like it. I don't call it zero. I actually usually. So this was what we just say, 437.5, right? So you're right, 437.5 pounds. Look, we already have the arrows. So pretend this is Tatum. Sydney is pulling this way, McKenna is pulling this way. What's Tatum's reaction? Pull this way, and her reaction is what when we pull this way? Compression. So big heat, those three things. Well then, honestly, if you look at this picture now, we need to go to, we started at A. So now why don't we go to, we could go to C if we wanted to, and do the exact same thing. I did not go to C right away. I went to D next. Does anyone take a guess as to why I went to D next? No, not the Pythagorean theorem. Tell me something, a special quality that member D has to it. All the lines are perpendicular. You guys see that? Okay, so that means I'm not going to have to do any sines and different cosines. I'm not going to have to find any missing angles because I know they're all 90. So if you trust me, watch how easy D is going to be. I'm going to go here, okay. D does not take up much room at all. I don't know if you guys can see my paper. This is D down here. That's it. That will fit. Here goes C. Here's the dot for D. I'm very, very fancy. There's the dot for D. D points to B. Don't draw an arrow on it, so we're not quite sure how the arrow should go. What else happened at D? It goes to C. Good. And don't put an arrow on because we don't have an arrow on that side yet. It is, all of these are 90 degrees, that is true. Good. And this one can have an arrow. What else? And it goes to edge. And you guys know what's really good about this one? We knew how to point it, didn't we? Because we had on the last picture, we knew the way that that one points. And what was the number that we had associated with it? Good. Please remember, since this points left, when we use it, we have to use it as being negative, and the points go up. I wonder if that arrow keeps using that. Arrows are very important. Make sure that when you use it, the negative number points go up. All right. Well, just like in the last one, I'm going to do the sum of the forces, okay? In the y direction, and we'll do the sum of the forces in the x direction. Good news. How many forces are there in the y direction? There's only 2 of them. We know that there's a what kind of 500? Good. And what's the name of the other one? V. That's really nice when you solve right now. What is CV? Positive 5. So make that little point. Up. Well, once I draw an arrow on this thing, put my little number here, so I have it as reference that I did it. I'm going to go back to my original drawing and guess what kind of arrow I'm going to draw? That arrow. And easy, it's not hard, is it? Well, if that one points up, guess what we can tell about the one above it? That's going to point down. Honestly, you guys should already know that that one is in tension or compression. Tension. You should already know that that one will end up being some type of number in tension. And in fact, we know the number, don't we? We just did the number. 500. So you are solving for the reaction forces of the numbers. Okay. Well, let's go back because we can still do a little more with these. We do the sum of the forces in the x direction. Okay. How many x direction forces are there? There's 2. Yep, there's DC and we know DA is what? Negative 262.5, right? I never put my A on here for that. It's negative because it points to the left. So what can we conclude about DC? 2 things. It's 262.5, right? Yeah. What else can we conclude? It points to the right. Well, pretty important once you draw an arrow on here. Go back to the original and draw an arrow on here. That was this one, right? Yes. This is telling you based on the forces that are being put on each force. Based on the force, like the 500 pretty much put on it. Based on that 500 force, how much force is happening on each individual part. And then what you can do further with that is knowing that the material it is and understand that pressure. All right, guys, if this one points to the right, this one right here, how's this one going to point? Yep. And you should know that this one's going to be, because the outside forces are pushing this way, it's going to be in tension, because it's wanting to push out. And we already have the number, don't we? Good. All right. We have one more to do. What's that? Well, we don't have to do that for D because we don't actually have any diagonals. We don't do that with diagonal lines. So we have to pick now if we are going to go to B or if we're going to go to C. There is an easier answer. What do you guys think? Do you think it's easier for us to go to B or for us to go to C? C is correct because it has less memory. B has 3 things happening. C only has the 2. Okay? Go to C. Oh, I should also mention, this is not going to be 437.5. Okay? Because this one is longer than this one.
Those two are always the same.
Right down here? No, they should not. Although, what's that? Yeah, the 500 that I know we changed it. I think if there was another fourth, like if there was a fourth over here, that would change it. I would say as long as the 500 is in the middle and it's perpendicular that this should be the same. I have to say that though. As long as there's only one fourth. Okay? You'll get to the point where I give you more than, like on this one there was just the 1/500 fourth. You'll get to parts where there's more than, there'll be a 500 here, there'll be a 250 here, there'll be 100 up. So, yeah, sometimes. Alright, letter C is our last one, I promise, okay? We're all done after letter C, guys. Here's C. Go to B. And go to B. We already know one of them, don't we? What do we know is CB? Oh, what was that? Did you say something very good? We do know that it's 252.5. Did you guys notice I forgot something else on my drawing?
Yeah.
Okay, it points this way. So when I use it, make sure you use it as being negative, okay? There's something else I didn't draw. Look at your free body diagram, like the answer one. Yeah, the 150. Okay, there is a, I should probably list it. There is a 150 source right here, and we know it's pointing up. Okay, now we have everything we need to go. This, by the way, is going to be very, very, very similar to A. Why am I grabbing the blue pen? What did I have to do before?
Yeah.
You do?
So you have to draw it right behind.
There you go, good. That's why I have the blue. This diagonal has to be broken up into a different component, okay? What should I, yeah.
Did you remember radar test inside?
Yes, I do have your test data. What is this one called? C, D, Y. And then this one is your CDF. But we don't know anything yet about this. Okay. Let's start with the Y ones, okay? Because we won't be able to solve for the Y ones really, really fast. Make sure I have everything written off in there. All right. Tell me about anything you guys see that's purely vertical. Tell me what you see as purely vertical. 150 CBY. Good. What does that tell you about CBY? Negative 150. Which means it's going to point. Yeah. Okay, good. Let's put that in. I was color coding this earlier. I thought that was clever, and then I stopped. Okay. So that one points down. Now, right away, you know what you should be able to tell me? You should be able to tell me which way CBX is going to point. How is CBX going to point? To the right. Very good. So it has to meet up with C. What is that? And, you know what else you can tell me? How is this one going to point? How is, if this one points down and this one points to the right, how is this one going to point? this sense? Makes sense? I was really talking about that. Okay. I promise you the sum of the forces in the X is not difficult. How can we do the sum of the forces in the X? What are these two horizontal lines you guys see? CB and I think I heard CBS. Good. Those are the two horizontal lines I see. What do we know about CD? What is it? Negative 262.5. Because it was one left, remember? And now we're going to solve for CBS. This won't be terribly hard. What is CBS? Positive 262.5, which kind of makes sense for it to balance the other one. So which way should it point? And it does, doesn't it? It points to the right, which means we did it right. It's because it's got positive. We did really good job. Okay, what's the only thing I haven't solved for yet? I haven't solved for B here. In this case, CB. You always say that where you are, CB. You haven't solved for CB yet, but you guys agree it's just made up of that triangle, right? It's made up of the green, orange, and purple triangle. And we know the green is, what was the green? What's CBY? I never labeled it, did I? 150, so we can do 150. You know what, that won't matter because it will come out when we square it. And then CBX is 262.5. So do we have to use sine, cosine, or tangent? No. It's a diagonal and we have the two other parts. So what can we do? You got it. So as long as you put a big square root, you do 150 squared and 262 squared, or 0.5 squared, that'll give you CB. So unlike A, we don't have to find the degree. You don't have to because the only reason we have to solve for the angle on the other one is because we had no information about our horizontal forces. Or on this one, since we did all our other work too. But if we were missing horizontal force, we'd have to solve for the angle to find it. I'm gonna cross off here. I don't, unless the direction says solve the unknown angle, we don't have to. I don't think that was part of it. You could. In fact, maybe we will just for good measure. But when you're solving for joints, I don't think you have to. I don't think you have to. And I will tell you this, they started at 8. So it doesn't really matter. I guess it depends on where you started in your life. I'll try to be more clear and like on my test, like, hey, also solve for all of them. What did you guys get? Good. Okay, so I can put that here. 302 pounds, which means I can finalize my answer over here. 302.3 pounds. Now, how did we have right here? How did we have our arrow pointing? We're pointing down, right? Okay. I'm gonna draw that on here. And if this one's pointing down, the one above it has to be up. Okay, and then just picture Tatum being in the middle of the two girls. The two girls are pulling apart, so what is Tatum having to do? Compress. So these are called the reaction forces of the knot. Okay? The last thing I want to do is just in case that you needed to. Because we did find out, right? This one was 2313. Somebody double check for me. Do I have that number right in my head? That was 2313. I don't think this is necessary, but let's say they ask you from that exam, they're like, hey, find the other missing angle. So remember, we're going to go back to C, which is right here. How can we find this angle right there? How can we find this angle if they wanted us to? Tangent, good. So I would do tan of theta equals which over which? 29? 29.74. Which, this is kind of neat for me to point out to you guys. So you get 29.74 if you do that second hand thing. Let's put that on there just in case they need it. 29.74. And yes, we're done with this problem, but I want to show you another way you could have got 29.74. And it would have been right here at the very beginning. Do you guys see how we could have done, instead of using the forces, and this is almost double check that we did it right. This is kind of, we could have done opposite. How tall is this bar? 4 over 7. Can you guys do that? What is second tan of 4 over 7? 7 is the same thing, right? So I guess even at the very beginning of your problem, if you guys want to solve for those betas before you even go into all this process, you can do that just using the length. But it was kind of neat. We went through such a double check to make sure, hey, our forces prove that we did it right based on these distances. That's kind of yes. It would probably be better to use the 4 over the 7 because those were given to us. We had to calculate 2.225, right? If I'm not mistaken, 2.225 was actually a rounded answer. I think whenever we solved for 2.225, pretty sure it was a rounded answer. So yeah, it probably would have been better to use our original 4 over 7. In fact, how about whenever we do these again, we always start by finding the same angles based on this. We'll just put them in there in our drawing. All right. So how do you guys feel about that one truss problem? Look what the directions say. I didn't really have very good directions for these ones. So I would say, let me look at the PowerPoint. Their PowerPoint that they give me. I think I hit it. I don't know where I put it. I'll look on there. They solve for them, but that's because they taught it in different ways than I teach it. So I would say, yes, let's just start on the very beginning. All right, guys. Do you have any questions at all for me? Long problem. We have, so that was a truss problem, and I should have at the very beginning, did we even check if this thing was, how do you say that? Determinate? Is that what we called it? Indeterminate versus determinate? Weren't those the words? Am I using the right word? Yeah. Okay. How could we have told, remember how we could have told at the very beginning that we actually could do all the math? You guys remember? 2 times the number of joints. How many joints are there? Like how many letters? 1, 2. So 2 times 4 is 8. Has to equal the different members, which is these individuals, 1, 2, 3, 4, 5. Plus how many reaction forces do we have? We only have 3 reaction forces. 1, 2, 3. So 5 plus 3 makes 8. So we actually, I think we actually did that in the right direction. All right. That I'm gonna stop recording that.